Okay, so let's take a look at this one. And so again, we're going to take what's inside the radical, make that greater than or equal to 0. And now be careful when you factor that, Emma, because you don't get to change the order of that. So it's going to factor x into 9 plus x 9 minus x. So the order on that subtraction is going to matter. Some people don't like to factor, they don't like the difference of two squares with the number starting. If you feel that way, that's fine. You can then fix that, but you have to do it by factoring that -1 out. And so then your factorization will still have that negative out in front. So then when you go to your number line, we're still going to agree that the zeros are going to be a -9 and +9. We'll put solid dots on there. On the blue one, if you plug in a -10, 9 plus -10 is negative, 9 minus a -10 is positive, the product is negative, and we don't get any domain from there. On this one, you would get a negative from this, a negative from that, and another negative from this. So the 3 negatives would still be negative, and you aren't going to get any solutions to the far left. Is that making sense? So when you plug in a 0, here you're going to get a positive and a positive, which will be positive. Here, when you plug in 0, this is going to become positive, and now the 2 negatives will still be positive, so we still get agreement. And then on the far right, when you plug in like a 10, this is going to switch to negative on the blue factorization, and this will become positive, and now we have 1 negative, so there's no domain there. So we say our domain here, because that is a connected region, and we do in fact get this double inequality that looks something like that. Is that okay? All right, back to the other group. Here's our next really challenging domain. So we're going to say h of x is going to be a big fraction, and we'll go with x minus 2 and x plus 3. Let's see if you can find that domain. Okay, just pitch it there and I'll get you a new one. Hold on there. Your surface. Yeah. Do we need to talk strategy? Are we okay? Anybody need a suggestion? Still in the nonverbal stage of morning here. So we want to know, where is the numerator going to be 0 and where is the denominator going to be 0? Those are going to be your two places where the sign could change from positive to negative or negative to positive. So you're going to set the numerator to 0 and the denominator to 0. How long does that take?
During class it's totally manageable, and then outside of classes it takes a little bit longer. Pretty much.
Wow.
Wait, you got greater than or equal to 2?
Yeah.
Not separate inequalities. You need a number line here. So you need a number line. So the place where the numerator is 0, you're going to get a solid dot because that's going to make the fraction equal to 0, and the square root of 0 is defined. Where the denominator is 0, you're going to get an open circle because that is undefined. But you got to check each of the 3 regions and see. Remember, because you got a fraction, so a positive divided by a positive will be in the domain, or a negative divided by a negative would be in the domain, but not a positive over a negative or a negative over a positive. Did we get them all? Good. Okay. Oh, you. For study them. Does anyone see anybody's homework? I think I have everybody in here. All right. I like it. Very nice. Do you want to see if anybody on those whiteboards needs help? So the boundaries for our graph are going to be where the numerator is 0, which is going to be defined because 0 over anything is 0, and where the denominator is 0 because that's going to be undefined. So a function can change from sign, positive, negative, negative, positive, either by being equal to 0 or by being undefined. So if we plug in something from the far left, like a -4, the numerator is going to be negative, the denominator will be negative, and a negative divided by a negative is a positive. So this will be in the domain, everything to the far left. Let me say that again. Are we good? Oh, I was looking at the one above you. You're good, Nora. So plugging in 0, this will be negative, and this will be positive, and the division, the quotient there is going to be negative. So that means that's not in the domain because the square root of the negative is not defined. Plugging in 3, we're going to get a positive over a positive, so that's in the domain. So we will say that we're going to get x strictly less than -3 or x greater than or equal to +2. Okey-doke. Very good. All right. Let's do a piecewise function. So we are going to, I'm going to ask you a few questions here. First, let me give you what the piecewise function is. And let's say we have the absolute value of x plus 2 plus 1 for x less than -2. And it will be x squared for -2 less than or equal to x less than or equal to +2. And then it will be negative, parentheses, x minus, I think that's a 3 squared plus 2 for x greater than 2. So here you're going to get not only the whole piecewise stuff, which is really tough, but we're going to see some of our translation reflection stuff that's part of this chapter also. And so I'm going to ask you first, so first, can you evaluate what is f of -4? Then can you evaluate what is f of 2? And then can you evaluate what is f of, we'll say, +4? And then can you actually graph the whole thing? Make sense what we're asking there? Okay, you can help each other out here. Go ahead, whatever side we're up to, the next group is there.
Can we go over this?
Yeah, please do. So as you're working on this, I'm gonna deal you out a review worksheet. This is your homework for next time. Got solutions with it. Let's see. I don't see you till the test, huh?
Yeah.
I bet you don't bring it to the test, though, so I'll just, yeah. What's that? When are we taking it? So it's at 8 o'clock in the morning, again, like last time. So 8 in the morning, Friday in the cafeteria. So remember, when you plug in -4 for F, how many answers should we get? Because to be a function, you can only have one output for each input. So that means you do not plug it into each of the 3 branches. You must decide which branch does it fit in. So because you're putting in -4 for X, is it going to be the top, middle, or bottom branch? The top one, because that's where you plug values of X that are less than -2. Boy, when you guys talk, just try to keep your voices down a little bit, wouldn't you? Let's see if, parking,
Yeah, sure.
if she's looking for a friend.
Yeah, I think we had it except for the last part, because it's down.
To go up and then down, yeah. 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 So I think this three is 1 bigger, -1 plus 2 is 5. So yeah, it goes, the last one goes up and then down.
So as they're still working there, are we agreeing on the A, B, and C part? So you have to figure out which of those branches you plug it into. Each value of X can only get paired with 1. So we do not plug, for example, -4 into all 3 parts of that. because it is less than -2, it goes into that top piece. Oh, the graphing part. So much fun for one problem. So we have absolute value, and you guys can keep working, but I'm gonna talk it through for people that are watching virtually. We know this is a V that's gonna open up, its vertex is gonna be at -2, 1. So I'm gonna do this one in purple, so we're gonna go -2, 1. There's your vertex. We got everything to the left. It was kind of boring to do it. I should have done that at X plus 3. It's kind of a bummer because you don't even get to see the V part because we never go to the right of that. We're planning. This one's going to be X squared. So I know it's a parabola that opens up. Question?
For the first one, it would be an open circle.
Very good. Thank you. So that's going to be an open circle there. Okay. Well, I missed the whole fun part of the absolute value. This is going to be a parabola. Its vertex is going to be at the origin, and it's going to end to the left at -2. -2 squared is 4. So we're going to go 2, 3, 4. That's going to be a solid dot. So we're going to get that part of it there. And at +2, it's also going to be at 4, also a solid dot. So we're going to get that piece of the parabola right there. And then we'll do this one. There's another parabola, but this one opens down, and its vertex is at 3, 2. So I'm going to go 3, 2 is there. It's going to open down. And I got to know where I'm going to chop it off at the end. When we plug in 2, 2 minus 3 is -1. -1 squared is +1. +1 times -1 is back to -1. Plus 2 is 1. So that's going to end in an open circle at 2, 1. So we're going to get that. And so we can see that none of the pieces of our graph connect. So there's a break in the graph each time we change to a different piece. Okay, questions on that? Okay, so we're going to do an inverse here. So let's say that, you okay on that, Jim? You okay on that? So let's say that we have f of x is equal to cube root of x minus 3 all over 4. I'm going to ask you a series of questions here. So we'll do these kind of one at a time. We'll do a first part of it, talk about it, and then I'll throw in the next part. We'll talk about that and so on. So first, can we find the inverse function? Can you find f inverse of x? Okay, and that's the other side. Gets a chance to get the ball rolling here. Do we need to talk strategy? Are we okay? Everybody knows how to find an inverse? Okay, then whoever's the next wave coming up to the board there. You okay? So you're gonna call or ask the x, y, and we'll switch the x and y. Okay. How many you know how to do is after that, is just a little lazy. Good to go? We all in agreement? Excellent. Do we need to walk through that or clarify a step? No? Okay, so you guys can go ahead and take a seat. The next question, part B, still the same. Now we know the function and we know its inverse both. And so now what we're going to do is to try to graph these. So we're going to graph y equals f of x and y equals f inverse of x on the same axes. And so you're going to put them on the same axes. Now, do we need to talk strategy here or no? So I don't know how you feel about it. I would just graph one of these and plot some points. And to me, I think it's easier to plug in values of x here. So I would plot like 3 points here. Make sure you label those. And then to get the inverse, what can we do? Just switch those x, y coordinates and then connect them. And if you're coming to the board, what luck, because you have different colors. So you can even graph these in different colors. Okay, other side, we're going to pick it up where we are left off. So it won't be distraction. Let's see if anybody needs help. Nora is available for a consult. She's looking for something constructive to do with her time. And she has finished this problem. And as a check, you don't have to graph the line y equals x on there, but it's kind of nice to see visually that they are in fact going to be reflections of each other in that line y equals x. And so you can see that points that has the same x and y coordinates, like we see -1, -1, that is going to be a shared point between the two because it lies on the line y equals x. Its x coordinate is equal to its y coordinate. And when you reflect one curve in the other over the line y equals x, that stays put. That doesn't move, and so it's a shared point between the two curves.
I need some sort of autocorrect for my graphs.
What's that?
I said I need some sort of autocorrect for my graphs. There's a lot of dumb and roll for where
You know, I was standing back here thinking, I think Jeremy's looks way better than mine. I'm kind of feeling like a little graphing shame here. That looks really nice.
Which aspect of, like, since it's like a cube equation, which aspect of it determines how curved it is, like when it goes up and then it kind of goes horizontal, or if it goes like.
Yeah, it's gonna be that coefficient here, because that's a vertical stretch.
Okay.
So and we'll talk about that in not too long in this next chapter, but if it, if we have our kind of basic cubic, which we know contains 0, 0, 1, 1, and negative 1, 1. So that kind of gives you the parent function, that kind of how narrow or steep is it swirling wise as it comes through there. And as that gets bigger, this like gets stretched more this way, because that point when you plug in 1 for x, instead of giving you 1, it's going to get multiplied by 4. So it's going to be way up here and down there. So it kind of stretches it, and all of a sudden it doesn't look like that familiar shape that is kind of looking, it's almost hard to distinguish between a line in a sense. But I think I like Jeremy's because it shows that it looks very cubic. Mine doesn't look very cubic. Okay. Questions on that part? Okay, so the next part's tricky too. So we got A, B. Now we're going to go to C. So part C, I'm going to leave this part up there. We're done with the graph part. So you can erase that. And C, we're going to verify that F and F inverse are in fact inverses. So this means something very specific. What specifically does that mean that you have to show? Yes.
You have to find that f of f inverse of x is x, and f inverse of f of x is also x.
Exactly. Did we catch that? So to make sure you say, which one is f of f inverse and which one is f inverse of f as you do this, because on the test, if you don't say, I assume you don't know, and so it'll cost you a point. Okay, so which side did we leave? The other group is up, and you're going to do a verification that these are in fact inverses, that satisfies our definition of what it means to be an inverse.
So could you just write it like that?
Yeah.
Okay.
Yep, sure could. Everybody's following your lead there, Ronan. So Ronan is using the f composed with f inverse of x. You could also write that as f of f inverse of x. So either one of those is okay, just so we're clear. I'm just going to write this down so they can see it, but I think we are on the right track there. So we're going to plug in for x, this 4x cubed plus 3 into our function f. And then we'll see that the 3's cancel first. So you have to do this step by step. So So that becomes 4x cubed over 4. Now we can cancel that 4. So then we get to the cube root of x cubed, and those cancel, and we get x. So we're halfway home. And then we can say, go f inverse of f of x. And that's going to be f inverse of, and the f of x is this crazy cube root of x minus 3 over 4. So I'm going to change colors here. So that means we're going to put that. So we need 4 times that cube root of x minus 3 over 4 cubed plus 3, according to our f inverse. The cubes are going to cancel. So now we have x minus 3 over 4. The 4's will cancel. And we'll get to x minus 3 plus 3, and then finally the 3's will cancel, and we'll get to our x. So a couple of things that I want to be clear of. If you do not write this initial step here, and I don't think you know which one's which, and you're just hoping to bogart your way through it, so that'll cost you a point. Also, somebody is going to do this. I hope it's not you. Somebody is going to plug this in, and they're going to do this. Cancel, 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 x. It's kind of hard to tell which happened in which order when you do that, because I wasn't present for the canceling. So don't do that either. That won't score well either. Questions on that? Very good. Okay. A different kind of problem for you here. So we will say that we have this unknown function. We are going to call it, we'll say that w of t is the weight of a puppy t days old. It's the weight of a puppy in pounds t days old. Okay, can you interpret in the context of this problem, what does it mean if we say that w of 3 is equal to, say, 1.7? And then what does it mean if we say w inverse of 4 is equal to 2.1? W of 4 is equal to, we'll say, 10. I have no idea. I'm making up puppy facts here, so I wouldn't put any validity to this. Other group, come up and give us an interpretation there. So people that are in here, you got the review. It's due tomorrow. Obviously, I can't check it tomorrow. If you get stuck on any of those, or you have some questions, you need to come in and see me or email me or something for an explanation, so that you understand it and it's clear in your mind before we come and take the test on Friday morning. Okay, so before school, if you come in before school, they are saying what they want the protocol to be in the morning is they won't let you through the doors here. They won't even, I don't think they even want to let you in the building until 7:30. I'll try to get here 7:15 or so, or maybe even a little earlier. But if you want to come in early, they want me to meet you at the door to let you in. So if you recognize when you're out there where my room is, if you see the lights are on and I'm in here, if you knock on the door, I'll come and let you in. You can come get help in the morning, or you can come in after school as well. Remember, if you are interested in retaking the last test, you have a very narrow window left to you. So it has to be done by Friday, so you need to come in like after school today. We can make corrections and go over it and quiz you on it. And then we can find a time for you to do the retake tomorrow so that we'll have that off the table and we can concentrate on this test. If you want to do test preparation, you're welcome to come in after school today, and we can do practice problems, kind of like what we're doing here. We can do more of those. So what does this one mean? It means that in 3 days, the puppy's going to weigh 1.7 pounds. Now the input-output is switched, so this means the puppy will be 4 pounds in 10 days. Okay? So it's going to be tricky, the inverse stuff. Very good.